we're going to construct a 100 times 1 minus alpha percent confidence interval for an unknown mean. Okay, to do this, and you'll be given certain things in your question. You'll be given some data. In this case, we'll say our data is 10, 12, 14, 16, and 9.1, or we'll be given some statistics. And the statistics will be given are an x bar, a sample mean, which in this case would be 12.2, and a sample standard deviation in this case, which will be S, which is 2.83584. Okay. You'll also be given a sample size, okay, and in this case our sample size is 5, as you can see. Right. And so we want to construct a confidence interval. Now that means you're going to be given one more piece of information. You're going to be given whatever this percentage is up here, which will be a confidence level. Okay? And so we'll suppose in this case that our confidence level is 95%. Right? Now we can use all of these pieces of information to go ahead and create our confidence interval. The way we're going to do that is we're going to compute two separate numbers. The first one being x bar, which we already have, which is the 12.22. The second thing we're going to have to compute, right, is this thing called a margin of error, which looks like this. It's going to be a t alpha over 2, so it's a two-sided critical value, right, and with degrees of freedom equaling n minus 1, and then we're going to multiply by s over the square root of our sample size. Once we have all of those, what we're going to do is we're going to take our x and we're going to subtract that e from it, that thing called the margin of error, and then we're going to take that x bar and we're going to add our margin of error to it. And what we will get are two numbers. There'll be a lower number and there'll be an upper number. There's two parts to the answer here, a lower number and an upper number. Now we need to calculate our critical value for this, and if you remember how you do that on your calculator, let's clear this out. We can do that using the inverse t function, and notice in this case that we have 95%, so that means that our alpha is 0.05, which means that in this particular case we're looking for alpha over 2, which is 0.025, and our degrees of freedom would be 4, since we have 5 pieces of data. So what do we type in this? Our area, the first number we use in this, is going to be 0.975, and our degrees of freedom is going to be 4. And we'll hit enter on that, and the calculator will search, and we'll get 2.776445098. And now, just for us to be consistent amongst each other, we're going to always round this guy to 2 decimal places. Right? So we'll say that our t of 0.025 and 4 is going to be equal to 2.78. That means if I want to calculate my margin of error right here, I'll use 2.78. I will multiply times my standard deviation, which is 2.83584. Whoops. Let's clear that out. I forgot to hit my times. So I'll do 2.78 times 2.83584. And the calculator's not playing with me too well right now. 2.83584. Then I'm going to divide by the square root of my sample size, which in this case is 5. And I will find out that my margin of error there is 3.525. So I'm going to round that to 2 spots, since I have 2 spots here. So this margin of error is 3.53. And so to get my upper value, I'm just going to add 12.22 plus 3.53. That will give me my upper value of 15.75. And then I'm going to do the same thing, just subtracting that margin of error with a minus there. And so I'm going to hit enter, and I'll get my lower value of 8.69. Right. So there's the lower value, there's the upper value. Now you can do the same thing with a built-in feature in the calculator. Right. The way you do that is if you're given the data, straight off what you do is just make a list. I'll just make a list here, and I'm going to clear out my calculator. So I'm just going to pull all my data in list 1. So I've got 10, I've got 12, I've got 14, I've got 16, and I've got 9.1. And it doesn't matter if I leave the other numbers in there. Right now I just need the list 1 there. And now what's nice about this is to do this, I'm going to hit on Stat, and I'm going to go over to where it says Tests up at the top. And then a function that will do all of this in the calculator for me is this function number here under Tests. Remember, I hit on Stat, I went over to Tests, I went down to this thing called the T interval. I hit on Enter, and now it asks me, do I have data or do I have stats at the top? Right now I have data, so I'm going to leave it on that. I put my data in list 1. I don't have a list of frequencies, so I can leave the number 1 there. And then I just type in my confidence level here. And you can type it in as a decimal, or you can type it in as just a percentage. I can type in 95 right here, and I can say calculate, and it will think about it, and it will come back with 8.69 and 15 point. Now it says 0.74. The reason for the slight discrepancy between the two is the calculator keeps more decimal places than we did there. So if you're going to do it by hand, I said just pull that too, but just realize if you do it with the calculator, you get something a couple decimal places different down the line. Right. Now, this was all done, using the calculator, and if I had a list of data, right, you'll notice on the calculator it actually calculated the sample mean and the sample standard deviation for you right there. Now, supposing you're given these numbers, you'd do the exact same thing almost. If you weren't given the data, but you were given the mean and the sample standard deviation and your sample size, you'd hit on Stat again, you'd go over to Tests, and again you'd go down to the T interval, right, and go over to Stats, right, and then it'll ask what you want. Now it happens to have these numbers left in here because I just computed them, but what you'd end up doing is whatever values you were given, type them in exactly. So even if it goes like 27 decimal places, type in all 27 decimal places someone gives you. Okay? So the values are 12.22. Since we actually calculated this right now and they're sitting in there, we'll just leave the whole thing in there. This was my rounding of it after a couple of spots. But the calculator actually filled that in for us. It won't always do that, especially if you haven't just typed in the data, but you can type in the numbers you're given, a sample mean, a sample standard deviation, a sample size, and you go down and say calculate, and it'll come back and it'll give you your lower value of 8.69 and the 15.741, which again, when we did it by hand, we did a little bit of rounding, okay, and so we get something slightly different. If you want to get closer to the, I said for the critical values, we're going to keep 2 decimal places if we're doing it by hand. I recommend doing it in the calculator, less stuff to type in, and so that'll calculate one of these confidence intervals for you. Again, you get a lower value and an upper value. Okay, that's it.